So welcome to the second episode in a series where I'm challenging myself to make the highest quality DIY PCBs using a very low cost CNC router. So we're still mainly doing some setup of the CNC in this episode, so we're not really making any PCBs as such. Mainly we'll be focusing on making some custom tooling, probing and mounting. All sounds very interesting, doesn't it? But first up, let's go back and test those endpoint switches that we installed in the last episode and make sure that they're all working. And well, let's get straight to it. So with the endpoints installed and everything set up, I'll give you a quick look at how this homing seems to operate. Press the home button. You can see it sort of does a fast seek until it hits that hard endpoint and does a slow seek. And the X and Y axes seem to do the fast seek and the slow seek at the same time. And that's it. So there effectively is your far left and far bottom position. I've actually set it up so that it seeks pretty fast without sort of smashing into the switch, so the sequence is much quicker than the standard default settings. And I've set it up so it goes back about 2 mil, so it clears or stops depressing the endpoint switches. So that seems to work well. And I've also got the software endpoint set up, so now if I, for example, let me just set up something here. You'll see it actually hits that endpoint and stops and allows you to come back. So it doesn't get to the hard endpoint. Now if you get to the hard endpoint, it actually gets into an alarm state. And obviously that's no good. When you come back the other way, it works. Now the interesting thing about the soft endpoints is that the right hand side one works fine, even if you do very small increments, but the left hand one is actually set at the hard point. So right now I'm moving quite large steps by about 10 mil per step, I think it is. But if I reduce this down to 1 and then move slowly so that we're coming closer to the hard switch, it will actually hit that hard switch and then get into the alarm state and it won't allow you to recover. So this is really weird. I mean, there must be a way to change the settings and I'll see if I can find it. But the soft settings give you protection on the going to the extremes, but the soft settings seem to use the hard endpoint position as your 0 point. So it's really weird. I really don't understand why it's that way. Maybe somebody can tell me. It's quite frustrating because obviously after we lock up like this, we have to go through and press this reset and unlock and all this sort of garbage, and then we're back in. And then another peculiarity is then once trying to get clear of this switch, right, we're currently depressed on this switch, we go to the right, it goes, it's still working, and now it's released, right? But now, as it released, it again goes into the alarm state. I just don't know why that is. Is this meant to be this way? I don't think I've got anything configured wrong, but maybe I have. So again, we have to go over and clear this, unlock it. And now I can do one more move because if it were clear, and we're all okay. So yeah, I don't know, it's really weird. And that works on all of the axes the same way. The peculiarity where the software provides you protection on the extremes, but it doesn't on the extreme far away from the 0 point, but the 0 point is actually set in the software protection as this point. Yeah, it's really weird. I also went through and I changed the accelerations and the speed, so I maxed it out. And effectively, you just need to max it out until until you don't have problems with the stepper motor missing steps. And it goes pretty fast. Let me see if I can crank this up to the maximum. So it's pretty quick, right? It's about 3 or 4 times faster than the default settings. You'll notice that I'm stepping currently by 100. Maybe you see that or not. The interesting thing about the software protection is that if the step you make will exceed the defined software endpoint, it won't do the action. So this is why you get this sort of distance here. So if I change this, say for example, to 5 mil steps, 5 mil steps there, then we can get right close. And if I go to 1 mil, you'll see that the extents protect you, not the switch itself. So the extents are set less than the position of the switch. See? It depresses the switch, but it's not fully impressed, it's not on, so it's not in the alarm state, and that means I can go back out. Yeah, pretty weird. 13mm. Looks pretty good, right? Let's put a chamfer on it. We'll be done. Alright, next up I have this little probe which you'll see me making, or have seen me made in the video. I've just tapped a screw on the back here, a little wire, so that my probe, I've just got two alligator clips here. This is so I can have flexibility to use on PCBs or other metal surfaces directly without having to use this probe. This will work well, and on this end here I just have a post on here that I can clip onto. So I'm going to test that next. Got everything connected up. Let's see if this works. Probe. Okay, move the probe out of the way. Now this is meant to go. Oh, there we go. I think that looks pretty good. Nice. Okay, so we've done the probing, so let's do a little test to see how it cuts. Go. So we've moved to the garage where I can manage the dust a little bit better. This is my very important dust management system, which consists of a cardboard box. Let's lift this thing up. There we go. So there it is. And this is just a home ventilation fan. I set up this thing a little while ago with a tube on the back there for ventilation for a paint room which I had temporarily set up. It's going to do the job here too. It's a pretty low volume sort of air, but it keeps the air moving. And I've got a couple of holes in the side of the box here to allow the suction, and I put an intake there with a filter on there as well. But it should do the job, and also I can use it when I'm using the laser as well to provide some protection. Also cut out these couple of spoil boards here. I'm going to use an instruction I found on the internet. I'm going to cut those up and level those off, and hopefully then I'll be able to start doing something useful. Maybe. So I've put masking tape there on the bed. This is what's recommended, is you use masking tape and then some super glue, whatever you want to call it in your country. And this is also a yellow tape. That's all they have in Japan. I couldn't find any of that lovely blue tape that everyone was using. And obviously I'm going to glue that onto there. So that's going pretty good so far. Let me glue that on there, and then we'll face this off, and hopefully we'll have a level bed to work with. And glued and clamped on there, so give that 10 or so minutes to set, and then I'll level it off. Yeah, had plenty of those screws, so more the merrier, I guess. So I'm just about to machined a couple of PCB hold down clamps from these slabs of aluminium I have here, some smaller ones and a larger one. So I've just squared everything up here and I've got this wasteboard here. I'm using the method to use masking tape on the wasteboard side and on the material side, and then using some super glue, whatever you want to call it, to actually hold it down on the material. I'm also going to use an X and Y probing method. This is a probe which I machined, a probe pole I suppose, and I have one side of the probe connected to here at the back here. You can see I've just got it clamped on there, and I've got the other probe here. So this should, in theory, if I've got the G-code script correct, it will actually probe both of these faces, the Y face and the X face. Alright, let's see if this is going to be a disaster or not. And there you have it, that's the little probe. Coordinates here, the offsets are a bit different because it's moved. And I'll send it home. And that is now, can't really see, but it's actually on that corner, so yeah, it's working well. The G-code commands for doing the probing on the X and Y axis are fundamentally the same commands. You just specify the X and Y axis and when you're doing the probe command, otherwise it works the same. So I've just created a little sequence. That's my little sequence here that I'm using to do the X and Y probe. Okay, so I've got everything set up and I've got the G-code loaded here for the bracket. It's pretty straightforward. You can just see that it's going to cut around a nice sort of corners, and in the center here it's going to cut some holes, and then it's going to cut a piece across the top here for the clamp. You'll see when it's finished, you'll understand it. Well, that worked out a lot better than I thought it was going to work. There's the 4 brackets now printed out, cut out, whatever. You can see this one here we haven't got quite through. It's still got about 0.1 mil left, so I'll change the program. So there's not enough depth in this CNC, so I have to slide this board forward. I'll take these 4 off and just slide it forward, and I'll cut another 2 and another 2. But I'm pretty impressed with the result actually. I thought this was likely going to end in some degree of failure, a couple of broken bits and at least a pretty messy result. But this result is quite usable. The downside of this result is the amount of time it took to cut these 2 pieces. It takes like 3 hours with this current spindle, and this spindle is really weird. It's like slowing down and speeding up, and you know, I knew this was going to be bad, so that's just the way it is. One of the good things that I sort of found out about this upgrade, about this Z-axis upgrade, is that this extra range here means that there's a lot more ability to have a longer tool height here. So even though you lose a little bit of work height, you gain so much tool height that you can, you know, it's a lot easier and a lot more flexible to work with. This is a pretty big plus in that regard. And obviously being able to mount the laser is a big plus. And finally I'm going to be able to mount a bigger motor, which is obviously necessary. But as far as the rigidity, you know, it's not really that much difference to the original one. I think maybe a slight improvement. So I've got this all set up for round 2. Should be no problem, ready to go. Just take these pieces off, slide it forward, and just having a quick look at these pieces I haven't cleaned up at all yet, but you can sort of get an idea of what they look like. But I'll give them a bit of a light file or a sandpaper and clean it up. You can see this one here, I mean, it's basically just about cut through. It's just like the last 0.1 mil, so it's just like paper there, so just push those through. But yeah, not too bad. And that's the little rut that I cut for aligning the boards, basically. Two more down. Very nice. See if we can get these off here. Oh, they come off pretty easy, don't they? Nice. Looks like we're finally all done. Alright, let's clean it up and get them off. They look pretty good. So let's have a look at the quality of the cut, just to get an idea. So this is all rough cut. I didn't do any care on the finish cut. And as you can see here, the top two look pretty clean. The second from the top, you can see there's some sort of chatter going on. But the thing I take away from it is that it is quite possible to get, I mean, these look quite okay, right, these cuts. Again, we see some chatter here on the front. And on these last ones, let's have a look how they look. Yeah, it looks like there's plenty of chatter there where it's doing those deep cuts, but where it's doing just the narrow cuts, like this one here, they're very thin cuts on the side, it's really quite a usable finish, I think, actually. So the lesson would be, you know, it's an obvious lesson. Rough cut and maybe just finish cut the last 0.2 mil. If you probably set your job up that way, you're going to get a pretty clean cut, clean finish and minimal cleanup afterwards. But I'm pretty happy with that. So I'll clean that up, and next on up we'll be cutting all of the holes in this waste board, which I'm going to use for the PCB cutting, which we'll be able to mount these little hold downs on, hopefully. So there's the waste board for my PCB cutting, all complete. You can see the holes here for mounting it onto the CNC, and on the other side here I have these holes here which will allow me to use my little clamps, which I haven't finished yet, to actually clamp onto the board on all sides. And I've got two sizes of clamps, so if the PCB is small I can use a smaller clamp. So that's going to work pretty good. So all I have to do now is push in all of these nuts. Now originally I had actually a second pass to actually finish this off to a perfect shape with a 1mm bit. These are cut with that standard 3.175mm bit. But after actually doing the first cut, I didn't do the second cut because I found it unnecessary, because these actually are just right for having a bit of a friction fit, and I can actually push them in quite tight. So that's going to work out well because I can just hammer them home and they won't fall out, which is obviously what I want. I don't want them to fall out. That's obviously not all the way home now. And then it will allow me to screw from the top like that. That's pretty good, right? I'm also going to put a home, this is the 0, corner here. I'm actually going to put a piece of aluminium or something on the corner here, which will allow me to probe 0, in case the CNC loses its mind or the PC resets or whatever, or somehow it loses. I think the CNC remembers it anyway, but in any case, if things get out of whack, I can actually have some sort of reference to come back and reprobe and then finish my work. So whenever I start a new board, I'll probe. Obviously I'll fix the board down and I'll probe, and I will then take a reference of the probe information relative to the 0 that I'm using on the board for cutting. Well, it's pretty easy, got them all in, just tap them in. They went in pretty easy, but I don't think they're going to fall out. No, they're not going to go out. Okay, so I've finished my waste board system that I've made for making PCBs, but I think it probably could be used for other things as well. These sort of thin hold down material. You can see how it's sort of holding down there, just has a little gap, just a little bit of pressure. These PCBs are about 1.5mm, they're pretty thin, so. But yeah, I think it looks pretty good. And lots of adjustability. These are all 20mm centers, and this is also allows the full adjustability at the 20mm, so I think there's not going to be a spot where you're not going to be able to clamp it down. I think it's going to work well. And obviously I have these smaller clamps as well, which is for thinner type boards if I have any that I wanted to work on. But you can sort of see the way that I finish these off. I've just done a bit of finishing work, spent a couple of hours sanding them down and cleaning them up a little bit so they don't have any sharp edges or anything like that. And on the corner of the board here I've added this 0 point probing location. Alligator clip with this clip on here, so I've got a little M3 bolt on there, so I think it looks pretty good.
Obviously, if you remove this, you're going to lose the position in any case. So the first operation, if you're going to do multiple operations, for whatever reason, you want to put some pins in, some holes for some pins. And I've made some, I think it's 3mm pins already on the lathe, using some stainless steel wire. So, first operation, put your locating pins, and that will locate this board always to this. And same with the double side as well. As long as it's symmetrical, you can flip it over and do your double siding operations as well.
So I've even got my laser going here, which is great. It's working really nice. I haven't cut anything with it yet. I'm using laser GRBL, which is the all-for. And I'm just using this little lab power supply. It's a 12-volt supply. Some complicated little split off of cable here, because obviously the main controller is not going to be able to provide enough power. Haven't cut anything, as I said, but I'll do that second. And the second thing is I'm using this probe here to adjust the height, and I've set up a couple of custom buttons there to do that. This laser GRBL is pretty hopeless actually, but I'm trying to stick to the free world for now. Maybe I'll end up having to buy Lightburn or something. It appears everyone sort of gives up and buys that in the end. So now it's sort of working okay, so we'll see how it goes.
Okay, so we're jumping around a little bit here. The experiments with the laser cutting, etc., I finally figured out how to make that work. Managed to cut out pretty cleanly these little shapes here, and the precision is great. I mean, that's amazing that you can cut that. So in the end, to minimize the amount of sort of smoke edging and things like that, I'm actually running it around about a feed speed of 500mm per minute, and I'm actually doing 5 passes at that speed at 100% laser power. And every time I do a cut, so I focused it exactly 20mm from the surface, which is meant to be the engraving height apparently, and then every time I do a cut I actually drop the head down by 0.8 millimeters. So it literally drills down silver like a CNC bit, but the result is very impressive actually, and it's basically no kerf, so everything slots together perfectly. I didn't do any adaptation or curving. This is actually just made in carbide created. I'd set the grid pattern to be the thickness of the material and just quickly drew this up. It only took literally maybe 2 minutes maximum. Yeah, quite nice. So anyway, that's enough for the laser for the minute. I just wanted to make sure I could get it to work. Next up, I'm working on the PCB stuff, and I need to make a spring bit. So what I need a spring bit for is, normally these types of bits here, these V bits, are rigidly held in the collet, which is fine when you're cutting. But there is a surfacing operation that I want to do, which removes the material from the solder masks, and that allows you to solder to those areas. And to do that, you need a spring bit. So a spring sits behind here, and the depth is set pretty arbitrarily, so it just places some degree of pressure on the PCB and then clears that area. So that's what I'm going to make it. This is a bit of a old material, which I've again salvaged from a printer. Hopefully it's not going to be too hard, but you can join along if you like and watch me make a mess of things again. Alright, so let's get to it. Alright, so I revisited the spring because that last spring I was using was a little bit too strong, I think. It's not going to be any good. So thankfully I have this container of springs of things that I've disassembled over the last couple of years. And I found something which is a little bit better. But anyway, this is with the new spring in there, and it only takes a fairly light touch. I can do it with my finger with that. So obviously the deeper you attempt to cut, the more pressure there will be, so there'll be some adjustability there. But anyway, that's much better. So just a quick little show and tell of the few bits and pieces that I had to make so far for doing this. Obviously I have this 8mm probe that I machined, and that's what I'm using to probe the X and Y. You can see it's got a bit of scratch from where I've got it installed in the collet there. But overall the finish is pretty good, and the accuracy is pretty good on that. And then I had a couple of failures on doing the spring bit for clearing the solder mask. And you'll probably see the machining, or you have seen the machining that I already did for that. So this is the first one I tried to make, and I got the depth wrong or something. I used the wrong length, or the depth is wrong or something. It's probably the wrong length. Anyway, it was no good. So get rid of that. And then this is the second one I made, which looked pretty good. The finish is not perfect because I didn't use the round bit to finish it off. I used the insert. You can see, even with a bit of a run on sandpaper, you can see those ruts in there. But the thing that I found out is after I took it out of the lathe, I found out that this was too tight. And so I put the bit in by hand and loosened it up, but I loosened it up too much. So there's a little bit of play here, sideways play. And you know, I don't want to introduce any more run out, so I really wanted that to be tight. So sure, it's moving well, but this run out was too bad. I had to make a third one. Before I made the third one, I tried to make one out of brass because I thought it would have given better running, and then I found that the brass was a little bit too soft, so I gave up on that halfway through. So this is effectively the fourth one that I made, and the finish on this is much better because I did bother to use the round bit. And I only used one small hole for the air relief. You need an air relief because obviously the fit is so tight and might have a little bit of oil in there that basically it won't move. In the second one I made, I actually had a larger hole on both sides. In this one, I did the hole. And the other thing that's different about the manufacturing process is that I did these holes after I took it out, but that actually left them burring inside, and that was a little bit of the trouble as well, as burring was inside and I couldn't really clear it out. So in this case, I originally drilled the 3mm hole, and then while it was still in the chuck, I then actually drilled these holes in place. First the smaller hole on either side, and then after that I also tapped it and whatever. But after that I did the milling, and that cleans up all of the burrs.
And after that again, after the 3.175, it was still too tight. It's the same problem, right? It's the same machining procedure. So the solution was to use a bit of 400 sandpaper on the end of a Allen key, a thin arrow Allen key. I just wrapped it around the Allen key and just machined it and just kept doing a few runs until it loosened it up. So now it just works, and you can't absolutely have no movement, but it's basically no movement sideways now, tiny little bit, but it slides really well. So with the spring in there, I also filed the burr off the tip of the grub screw as well. Looks pretty good, right? And there's going to be a little bit of movement, but I think it's pretty good. Yeah, so this is a big success. So this is also 8mm. This is 8mm. I think 8mm is just about as big as you can go with the ER11 collet chucks. And other than that, obviously I made, this was actually 3mm stainless steel wire, or whatever you want to call it, pipe or pole or whatever. And I just chopped these off in the lathe and went to the effort of beveling both sides. So that's pretty much it for the preparation side of things for now. Next episode, we'll finally be getting to the weeds and attempt to mill a PCB with this little rig that we've set up. So don't forget to subscribe, comment, like, and I hope to see you in the next episode.